we're going to calculate some examples of area using our rules that we have already revised. So what we've got here is a triangle. We can see that the height of the triangle is running perpendicular to the base there. The base is 8 kilometers and the height appears to be 5 kilometers. Our area rule has to be written down first. So our area is base times height divided by 2. We've identified that our base is 8 and our height is 5. So it would be 8 times 5 divided by 2. 8 times 5 is 40, so our final answer there is 20 square kilometers, because we are also including our units there. Alright, what we've got here is a trapezium, and we know that our trapezium area firstly is A plus B times the height divided by 2. So we now need to identify which is A, B and H. Our top is usually our A, our B for base is at the bottom there, and we can see our height is running perpendicular to the base, so H there is 2. Let's substitute those numbers in. 7 plus 10 multiplied by 2, and then divided all of that by 2 as per our rule. It's got 17 times 2 is 34 divided by 2. 34 divided by 2 is 17, and our units are square centimeters here. We have a half a circle. Now we know that if we have a full circle, our area rule is pi r squared. And in this case, we know that we've got 180 degrees working here. So we could say multiply by 180 degrees divided by 360, okay, which is like a half, because we are working with a half a circle. So if we've got pi r squared, we'd have to say pi multiplied by, now what we've got here is this is actually the diameter from one end through the center and back out again. So in this case, our diameter is 1.8 centimeters. Our radius is going to be half of that, right? 1.8 divided by 2, which is 0.9 centimeters. So we can substitute in there. We've got 0.9 squared multiplied by our 180 on 360. So this time we'll grab our calculator out and we can find our pi button. It is down here, right, in my calculator. So pi times 0.9 squared multiplied by 180 divided by 360, and our answer is going to be 1.27 square centimeters. Okay, we can do our final one here. Once again, we have a sector of a circle, so we're going to have our theta on 360 for how many degrees we have multiplied by pi r squared. This time we actually have the radius going from the center to the edge, so therefore we have a radius of 5. So we can say we've got 76 degrees in this sector divided by the total possible 360 multiplied by pi multiplied by 5 squared. Again, make sure your calculator is out and ready. Your brackets, we've got 76 divided by 360 multiplied by pi multiplied by 5 squared. So our answer here is 0.58 square meters. You can see that when I'm doing this working out, all of my equal signs are lined up down the page. You can see that every single time the first thing that I write is a rule, an algebraic rule, before I substitute in all my numbers. I must see that rule before I see the numbers first and foremost.